All right, sometimes we need to do more complex probabilities. For example, what if we want to know the probability of getting an event A or event B? For example, one card is drawn from a deck of 52 cards. What is the probability of drawing an ace or a king? Whenever you see the word or linking to probability or linking to events, you should think of the property of addition. So for example, if we want to know the probability of getting an ace or a king, we could simply take the probability of getting an ace plus the probability of getting a king. 4 out of 52 plus 4 out of 52 equals 8 out of 52. How about this problem? An employer has 20 employees in the accounting department, 30 in the marketing department, and 15 in the legal department. If an employee is selected at random, what is the probability the person is from the accounting or the legal department? Pause the video here and see if you can work out how to do this problem. Okay, we have the word or here. So, probability of getting an employee from the accounting or legal department. We take the probability of selecting a person and that person being from the accounting department plus the probability that the person we would get would be from the legal department. Well, there's 20 employees in the accounting, 15 in the legal. That gives you a total of 35 employees out of 65. One card is drawn from a deck of 52 cards. What is the probability that the card drawn will be a king or a heart? King or a heart? Now, using the formulas we've done so far, we would just take the probability of a king and add it to the probability of a heart. However, this is problematic because these two events are not considered mutually exclusive events. A mutually exclusive event means that if one event occurs, the other event cannot occur. And it also means that some outcomes will be counted twice. See, there are 4 kings, but one of those kings is also a heart. And so when this event occurs, we need to subtract out those events that will occur twice. So we need to take the probability of getting a king plus the probability of getting a heart minus the probability of getting a king and a heart, because those will be counted twice. And this is a rule of addition of events that deals with not mutually exclusive. We end up with 4 out of 52 plus 13 out of 52 minus, this is a little misprint here, minus 1 out of 52, which gives us 16 out of 52. Okay, so here it's corrected. 4 out of 52 plus 13 out of 52 minus 1 out of 52 gives you 16 out of 52. Sometimes Venn diagrams are used to help you illustrate the difference between mutually exclusive events. For example, here we could draw the outcomes. We're drawing, this was illustrated the probability of getting a king or a heart. Now here the aces and the kings are completely separate, actually ace or king. And when events are not mutually exclusive, you'll notice the king of hearts belongs both in these group of cards and also these group of cards. So in summary, when you see a probability where you have to get event A or B, you have to determine if those two events are mutually exclusive or not. That should be the first question. And if the answer to that question is yes, you take the probability of A or B, probability of A plus the probability of B. If the events are not mutually exclusive, you have to use this rule of multiplication. Probability of A or B, probability of A plus the probability of B minus probability of A and B.